Hey guys, Emma again. Back in Queensland and back at work for a week. I've got a little project though that I'm thinking of starting, or I will start. And I run it past a good friend of mine who says, well, if you're serious about it, I'll race you. So we'll see how it goes. But I need someone to pace me, and I need someone to keep me motivated to finish things. So it's a little oscillating engine. The drawings are online. And there's a website too if you do make one. I'll post a link down below. But if you do make one, send a picture through to the guy and get him to put it on his website, because there is quite a few nice engines there. And he's taken a bit of trouble, I think, to make good drawings and a good usable little engine. So here's my first installment. And we're sort of ready to make a start. We've got a sharp tool and we've got a bit of inch brass there. I'm going to put that in the 3-jaw here and face it off. So I've set that up in the 4-jaw, in the 3-jaw. The problem is that my little 3-jaw hasn't got an inch hole in the middle of it, so it won't go right back through just to part it off. So I'm going to part a bit off first and then machine that. It's got to be 30mm long, so we'll go a little bit extra there. A little bit of length to machine. And we'll start her up. That's a bit fast probably, so we might just drop these belts back. Don't know whether that'll do anything on brass, but it's probably not a bad idea. I'm not sure if that parting tool's quite square on there, which it probably should be, but I only set it up by eye. So it seems to be cutting okay, and no problems with that. I've had a couple of comments that people want to see me actually do things, not just what I've done. So here we go, this is parting off. It's a fairly straightforward procedure really, there's nothing to be scared of. I'm going to bust that off there because it's going to jam the tool. Like that. And nice job. So because we don't have a quick change tool post, I'm going to stop the camera and change the diamond tool holder back on, the tangential tool holder, and we'll face the end of that. Well guys, that's the tool turned over. This is a great thing. This lathe would be so much more functional with a splined quick change tool post, and it probably will happen one day, but they are expensive and I'm just waiting my time. Maybe one will turn up. So we've set that up to centre height. It's not quite square there. That's got a bit of clearance, so and might just break that sharp edge. reversing, make sure that's so we've reversed that, and we get our rule. This has got to be 30mm, and it only wants a fraction off there. That's cleaned up nicely, so I might just run a nice finish cut on there, nice and slow. Still a fraction long, so we might just take a little bit more. It won't take much. So that's the cylinder face to length there. I'll put this back in the scrap box, and the next thing is it needs a flat on one side. I want 2.5mm in. Now, the way to do that probably I thought was to set it up in the 4-jaw. So, set a 4-jaw chuck on. Now, we're going to need to reverse these jaws. So there's a couple of ways I could do this. It really just needs 2.5mm off one side. There's a couple of ways I could do that. I could set it up here on the tool post with a bolt. That'd probably work too with a fly cutter or a milling cutter. I could probably do it on a V-plate in the tailstock with a clamp. I could probably set it up on a face plate and clamp it with an angle plate. This is probably the easiest way. Because this is already round and we only want to put a tangent on there 2.5mm deep, or a flat side, it really doesn't matter much where it is. If it's out here, it'll still machine the same, and it's out here, and it doesn't matter much which way around it goes. So all we've really got to worry about is getting it square that way. And probably the easiest way to do that, I thought, was just to set it up in the 4-jaw. So we want to get it somewhere near so it's not too far out of balance, but like that. You probably want to finish that can of soda I was just drinking and make some shims for this, I think, before we mark it up too much. So I might do that next. And that's about where we want to be probably. So I'll get some Coke can. So there you go, guys. There's a bit of soda can now, aluminium sheet. I guess it's pretty thin. Everyone's seen that. And just cut it out with a pair of scissors. And probably the easiest way is to just cut a piece to go round. Put some nice neat creases in it. It's probably easier than trying to manhandle 4 little pieces. Hopefully this way it'll just stay on the job a bit. It's pretty easy to crease up with your fingers. I can do that. And we've got a bit of shim, so we're going to set that up in there. There's only one problem with that, and I don't know if anyone's spotted what it is yet, but the problem is that there's no way of telling how deep we've gone. So probably the answer to that is to cut one corner out. And we can measure it. I'm only going to set that up by eye, really, to get it somewhere near close enough. It doesn't want to vibrate much, but there's not really, I mean, you could set it up with a centre punch mark and a dial indicator or a straight edge or something, and on a smaller lathe probably you need to do that, but this isn't a particularly big piece and we are having a race here apparently. So that's all I'm going to do is set it up like that, nice and tight. Hopefully that shim sort of protects it a little bit on the ends. And we're right to go again. So start the VFD, the motor, you see the belt running there. You can certainly hear it. And there's not a lot of vibration there, so it's running nice and true, I reckon. Put your scissors away or they get brass dust all right the way through them. Slide the tool post along. We've got a bit of an interrupted cut here for a start, so we'll just move it up till we can till we're actually taking a scrape like that. We might just check at both ends, it's scraping about the same. We might just give that a little bit of a tap on that end. There. There, that's pretty sweet there, so we might just cut it at that. There is a bit of meat to take off, so we'll take a couple of cuts and have a look at it. The thing that'll tell us is whether this actual blank here, have a look, is parallel, and that looks pretty jolly good to me, so I'm going to go with that. So don't laugh at this, it is pretty rough. It's not much of a caliper at all. It's Mako, it's plastic. It's carbon fibre actually, which may or may not be true. We need to find some way of measuring that. And that's probably good enough for this. We're going to measure the bearing to fit. So we were about 25.4 I think. We need light here. Sorry guys. and that's down to about 24, so we've got 1.4 down, and we need to go about the same again. So there we go, that's the flat. And that's what it should look like, I guess. It's nice and parallel. Everything looks good. I might just break those edges up again. Give that a bit of a clean up. Probably a bit more later on with a piece of glass and some emery paper. But just break that. That's a little diamond file. It's a good handy thing in the lathe. There we go. So next job is to bore it, and we're going to set this up just in the 3 jaw, I think, and get it about right. 1 jaw on there, and that'll give us an offset. The right amount should give us the right offset. I'm going to send a drill and bore at 12mm. I've got a 12mm reamer, so I'm just going to run that through it. So there we go. We're using the same bit of shim stock again. It's cut down to length so it doesn't touch in the middle and throw us all out. And in the 3 jaw, we're just going to set this up here nice and square. You'll never find a chuck key. I've got several ideas about how to fix that, but this is where it was. It dropped on my toe, that's right. So we're just going to set this up a little bit sensitive with your fingers so you get it nice and square and straight. Find a high spot. And clamp him up nicely. We're going to set the drill up and find a little cedar drill. And just touch it and see how it looks. If it looks about right, we'll go through and drill it. It's pretty well on centre that way. And it looks about right that way. So we're going to go in and drill that now. We'll set him up. So that's a bigger drill, that's 10mm. So just running a nice sharp 12mm reamer through there. I picked this up at a flea market here locally, which is a good reason to have a look at the flea market. And that's not a bad finish there, so we'll put this away again and give him a bit of a brush up. and put him back in his tube so it doesn't get knocked about. But surprising what you can find at flea markets. This is it's a custom thing for a machine somewhere. I don't reckon it's seen any use. It's out of a tool room that's sold up. It's just a straight flute machine reamer. It's a long one, which I probably wouldn't have bought, and I could chop the end of it off, but it's got a centre drill in one end, so there's not a lot of point, and it worked well. So that's something that's paid for itself. So that's pretty much finished that. I'm going to take this out. Give this cylinder a bit of a clean up now. It needs breaking the edge, and it might get a bit of a, it's not a perfect finish in there, so it might get a bit of a clean up with a hone before we finish the cylinder. That's the next stage. So it's coming together well. I guess the next thing is to make a lid for it. We'll find a bit of brass and make a lid for one end. The drawing, screw it on, and I guess you could probably soft solder it. Or you could probably just Loctite it, it'd be good enough, but if you're going to run it on steam, that's not so good. I might just put 3 little cap screws. I've got some Umbracos there, 2mm and 3mm Umbracos. I might put just some 3 metric Umbracos there. I like the drawings. They look neat and they're not really in keeping, but it's a modern engine, so why not? So the next thing is to make a lid, and then we've got to set this up somehow, and we'll have to have a think about that. Nice and square, and that is important, and drill it for the stud. So let's have a look in the scrap box and see what I can find in the way of something to make a lid out of. Well, I've had a look in the scrap box. There was another bit that I bought at a garage sale, or a yard sale, for 50 cents. It's not really big enough, I don't think. If you're going to silver solder on it, it'd just be ideal, but I don't think it's quite big enough, so I might have to use the end of this bit of inch stuff and part it off again. It needs to machine down with a step on it, and then just so that it's just under the clearance there, so it doesn't stick out, and enough room to put 3 screws in it. So I guess that's probably the best thing to use. It does stick out a fair way. Something about 3/4 diameter would be really good. So I guess the thing to do would be chuck that up and machine a step on the end so that it fits nice and neat in that bore, and then machine the outside of it down and turn it and face it off. It's a pretty straightforward little piece to make. Machine the outside of it. Doesn't need to be particularly long, this piece. So the drawing says that it only wants a 1mm lip on it to go in the hole, and then it wants to be 2mm thick, which is only pretty thin. Now, a bit more is probably better than a bit less in there, but the problem we're going to have is that if we're not very careful, you're going to block up the ports, which actually are only 10mm from the centre, so you've got a couple of mil, and your piston's not going to, is probably going to touch on the top, but I don't think it will. It looks like there's plenty of clearance in there just looking at the drawings. So I might just machine we'll go 1mm for a start, and a nice neat fit in that hole, and we'll see how it looks. So it wants a bit of an undercut in it rather than a round corner. Just move that back far enough to see if it fits. My eye's pretty good, and that's within it's pretty jolly close. I'm just going to take another cut and we'll try again. Like that. That's a nice neat fit on there. So that's about how it wants to be. Measure it, get it right. I mean that's a good fit. Get it right. Don't just rely on your eye. That's taken a few years practice to do that. And I didn't measure it. I just made it fit. So that's right. Now, if we have a look here, this is sticking up a little bit here, so it wants to be a bit smaller than that diameter. It's not sticking up. It is on this end too. It's about in the middle there. So we might take a couple of mil off the outside there, just a little bit. So that looks pretty sweet there. I'm going to get the hacksaw out and I'm going to cut this to length, turn it around and face it. So I'll turn the camera off while I do that. It won't take me a minute, but I'll go across to the vise and do that. Now, I've cleaned that up with hacksaw. Not even out of breath on that one. But it only took me about a minute to cut that off. There's a lot of people I know, or there are people that I know who are reluctant to do something in their home workshop because they haven't got any way of cutting a piece of bar off. I'm a big believer in hacksaws. It's a good thing. It's something that everyone needs, and it's a fairly quick sort of a way to cut anything off. So just get in and do it and you might surprise yourself how quick it is. So what we're going to do is chuck this up in the 3-jaw, right, on the flange, reasonably tight. You don't want to squash it, and we're going to face that off. So the thing will be to move that along a bit. And remember that it's only 1mm flange there, so it's not holding by much. And just take a tiniest whisker off at a time. What we need to do is mark a PCD on there, so we're going to slip this tool round. That looks about right. I know this tool will do it because I've done it before. and we're going to just mark that gently there. And what looks like a pretty fair PCD. And we're going to slip this belt off, do the next job, and turn the lathe off. We're going to have a bit of a look here. We've got a 24 tooth index wheel. We'll put this in place. We come in here to the 24. 3 into 24 is 8. So I'm just going to mark three dots here. That's 1, 2, 3, 4, 5, 6, 7. That should be 8 holes. And we'll go another 8. 1, 2, 3, 4, 5, 6, 7, 8 holes. And that should give us our 3 marks. So we'll take the pick off before we forget. And we've got three marks set up there, so we can centre punch them. Take this out of the chuck, make sure it still fits the work, give it a bit of a scrub up. So we'll take this out of the chuck and give it a bit of a clean up on that side. Take the sharp burr off there, which we probably should have done the first time round, and we did, I think. And we've got 3 marks there, if you can see that. So we sit this in here nice and straight. We'll be able to drill them and tap them. So that's the next job. I'll just drill these over at the drill press. I'm just going to centre punch them lightly and find some screws. That'll be next, I guess. So I found a tap. This is a M2 by 0.4. Got plenty of screws to fit that thread. You can pick them up just about anywhere at the local tool guys or screw and bolt guys. We're going to need a tapping drill and a clearance drill, I guess, for this. This is M2 by 0.4, so on any metric thread, any metric tap, it's very easy to work out the tapping drill size. You just take away the pitch measurement from the diameter. So M2 minus 0.4 is 1.6 millimeters is the tapping drill for this. So that's easy, and any drills, like any metric taps like that. If you've got a M6 tap, for instance, is 1 millimeter pitch. If you take 1 millimeter from 6 millimeter, you get 5 millimeter, which is actually the tapping drill size. So it works for all metric threads. That's easy and a good way to remember it. So what we're going to do is drill this top here, and drill this lid 1.6, and then put him on nice and square and see if we can get him nice and square, and spot the cylinder to drill later, and then drill this cover out, and the cover's finished. So that's the plan of attack. I'm going to do it across at the drill press, and I'll come back and show you when I'm done. So there we go. I've drilled them and put the two together. If your lid's a bit loose, and it might just be, there's a couple of things you can do. You can make another one, which kind of works. So you've got plenty of brass bar, that's not an issue, and it didn't take long. That's one option, and you'll get it better the second time. The other thing you could probably do is put a little bit of super glue on it and make it a nice fit while you drill it. That's not a bad option either. If we just give that a tap with that tap, excuse the pun, and there we go, we've got 3 holes there. So they're 1.6 and 3 holes in there to tap. They're fairly deep. It won't hurt to get them pretty deep. They're not going to interfere with anything, and it's less likely that your tap's going to break. So I'm going to drill this one out to 2 millimeters, and clearance for the screws. And that's probably going to do us for today's episode. So thanks for watching, and hope this wasn't too long-winded. I've tried to cut it down. I ended up with about, it's taken me, I guess, probably all up to do that, about 2 hours. So it gives you some sort of a ballpark how long it should take, depending on how fussy you are. There's a lot of people out there more fussy than I am. I'm probably going to tap these this afternoon and drill these and fit some screws and have a bit of a think about where I'm going to put the centre here, where I'm going to drill the stud and how I'm going to drill it nice and square. And well, thanks for watching, and don't forget to subscribe for the next update, and more soon. Thanks guys.